Okay, good morning, everyone. Till now we have discussed on module 5 with rigid payment failures and various components on rigid payments like causes, remedial measures, then functional evaluation. We have looked into a number of factors influencing rigid payment in terms of wheel load and its reputation, properties of substrate, properties of concrete, external conditions, joint reinforcement. Okay, so apart from that, the last concept we have on joints and types of joints, what are fillers which are used, requirements of fillers. Then we also looked into types of sealant material which are used for joints and design of joints with expansion joint and contraction joint. You have problems on that. So very little content is there in module 5. You can cover up in no time. Practice with failures of rigid payment and line diagram. I am repeatedly telling line diagrams of these failures are must. You need to practice that. So we'll move on with the last module what we have left with, that is module 4. Uh, so in coming lectures we'll be discussing on module 4. So here it is about stresses in a rigid payment. Okay, so it is of analysis. Design problems are there. So we'll be studying about type of stresses which are developed in rigid payment and how do we analyze these different types of stresses in rigid payment. And Westergaard was the first person to do the analysis of these stresses in cement concrete pavement. Okay, so we'll be analyzing these stresses with respect to Westergaard's analysis. And after some days, there were some modification in these equations of Westergaard's analysis. So we have modified Westergaard equations, which we'll be studying. Then critical stresses, as in one of the factor in rigid payment, we're discussing about this critical stresses. Can somebody remember about these critical stresses? What are these? If you could remember, I was discussing about these critical stresses or critical load positions on rigid payments.
Yes, so along the application of load, there will be
Yeah,
X component, Y components, and
it is with respect to three load positions. One is internal, corner, and edge position. So those are the critical load positions or critical stresses. And then wheel load stresses, wrapping stresses, frictional stresses, and we have the numericals on these three parameters: wheel load stress, wrapping stress, and frictional stress. Now again, these three parameters are caused because of load coming by the wheel of vehicles and variation in the temperature. Again, two things are there in variation in temperature. One is seasonal variation. Second is due to daily variation. So for daily variation, we have wrapping stresses. When we have seasonal variation, overall expansion and contraction, which leads to friction between the slab of CC pavement and the below layer. So that have some stresses which are developed due to frictional stress. Okay, and we have combination of all this. So combination of wheel load, wrapping, and frictional stress. It is very interesting. Combined stresses. So using chart or equations, we will be equation with respect to Westergaard equation. Okay, so this first part of module 4 we have already done majority of the things in highway engineering part in pavement design. Okay, so it is a kind of a repetition of various concepts. Okay, and then we have the next part, design of rigid pavement based on IRC. Okay, So here in IRC 58 2002, with reference to this codal provision, will be designing CC payment for dual and tandem axle load. Okay, so directly we'll be taking up solved problems are there in IRC 58 2002. So with respect to that, we'll be solving some numericals on IRC 58 2002 design of CC payments. Okay, then reinforcement in slab. Again, I told you reinforcement will be always in the form of bars, which we provide in transverse joint. So that will be in the form of dual bars. So design of dual bars again will be referring IRC 58. Solved problem most of the times the same numbers with numbers they are asked in the exam. Okay, design of dual bars, design of tie bars. Okay, again, and now they have mentioned here like factors for runway payment. The same thing has been mentioned over here also. Design factors for runway payments, design for factors of runway payments, design methods. Again, it is one big vast area of different methods are there, but I don't think I don't know how they have put this in the syllabus, but I'll be giving you certain list of methods, okay, in the form of notes. So you can just refer those list of methods, and factors remain same like what we consider factors a little here and there. Some factors are considered for payment design uh, of runways. Okay, so need not worry about this line. Design factors for runway payments, methods of airfield payments. I'll be listing and giving you in the form of notes. You can just look through those different methods. Okay, so problems are nothing but the design of dual bars, design of tie bars. The problems are this. Okay, so this should be clear. Don't think that this again this parameter we are neglecting and all. So uh, the major concentration whatever is been asked in the examination, that I'll be emphasizing more. And these design methods and problems on airfield payment, they have never asked till now. Okay, if you see the previous exam question papers and all, so they are not asked, and it is very vast also. Okay, I don't think they'll be asking any particular method on airfield payments and all. Okay, so this is about your syllabus in module 4. Okay, we'll start with the first part of module 4, stresses in rigid payments. We'll start with the introduction of rigid payment. And I hope you have just downloaded this. Okay, if you have not gone through, it's fine. Today is just the theoretical part I'll be discussing. Okay, now design of rigid payments. So in this module, we are discussing mainly on analysis part. Okay, so in previous module, we discussed on evaluation part, like what are the different failures, all those things. But in this module, we'll be discussing on what are the stresses which are causing in rigid payment and how do we analyze those stresses. Okay, so CC payments are often referred as a rigid payments. Okay, uh, so it is made of Portland CC cement. Okay, and the main advantage of CC payment is it is having high flexural strength compared to the flexible payment. So, so the main thing or the main component in case of rigid payments is the CC slab, so which takes up the majority of the load. And if any undulation or any defect which is found in the below layer, that can be taken care by the CC payment. And the overall cost of the overall life cycle cost of the payments, it is better in case of CC payment. Okay, when you compare with flexible payment which requires large maintenance requirements. Okay, but initial cost is comparatively less in case of flexible payment. In case of rigid payments, the initial investments, okay, is very high. That is one thing. Okay. And you can see a lot of national highways, lot of urban tier 2 cities, or even at the level of gram panchayats also, they are preferring rigid payment because of maintenance. They have the low maintenance cost per annual year per year. Okay. So that's why the uh, government agencies, they prefer rigid payments over flexible payment. Okay. So if designed properly, maintained properly, these run for minimum of 30 to 40 years with minimum maintenance cost. Okay. So some of the advantage I have just mentioned here, they have a long life, as I discussed. These are for designed for 40 years. And maintenance free, only maintenance part, I'm telling that it is only the maintenance of joints. If you maintain the joints properly with the proper filler and sealers, that is more than sufficient. Okay. And you always get a good riding quality in case of cc payment. No undulations as such you find in flexible payment. And you have better abrasive resistance. Okay. They have a high resistance for extreme weather. Okay. So if you go to the north part of country. Okay. If you see the country, geographical feature of the country and climatic feature of the country, north part you have the extreme condition. If you go to delhi and all, then the daily variation is very high. Okay. Morning or in the noon time, it will be going up to 40. And if you take the payment temperature and all, it is going beyond 50 degrees celsius. And during night times, what happens, the temperature drop down to 4 degrees, 5 degrees. So there is so much extreme variation in the temperature. So to withstand this extreme temperature, the always cc payments are preferred for. Okay. And always oil spillage and all, it reacts with the bitumen, and again further deterioration may take place. But there is no significant damage to the rigid pavement, or it is nullified when oil is spilling on rigid pavements. It does not react with cement. Okay. And always the economy in the I told you, the rigid payments are for higher life cycle cost. Okay. Life cycle cost is on a lower side when you compare for overall design period of these payments. Yeah. There are some disadvantages also, like if you want to modify with some utilities after the construction, it is not possible. And maintenance, if you find some maintenance like failures like mud pumping and cracks, localized cracks, block cracking and all, you need to completely replace. You don't have any minor maintenance which can be done and it can be repaired. Something you need to go for complete rehabilitation or complete uh, reconstruction of cc payments. Okay. That is some of the drawbacks which you find in case of rigid payments. Yeah, I think we have discussed on factors affecting uh, this they have already mentioned in module 5, like we have discussed these factors. But still we have in module 4 also, we need to understand about what are the different factors we consider for rigid payment. One thing is the type of loading, what is the magnitude of wheel load coming and its repetition. So it helps in designing the payment. Area of contact of wheel, fine. Location of load with respect to the slab. So these are some of the factors which we consider while designing the payment. We always go for properties of subgrade, like what type of soil is there, what is the strength of the soil, and what are the characteristics of the soil. Whether we need to go for submesh provision, or it can be omitted based on the strength parameters. Okay, so this is about the soil condition we need to know. Then if you are going for concreting, then what type of grade of concrete, what is the strength of it, what will be the modulus of elasticity, Poisson's ratio, mu, shrinkage properties. These modulus of elasticity, E of concrete, and mu, everything comes in the analysis of the stresses. Okay, so when you are finding out the stress in rigid pavement due to wheel load, then we require these values of E, mu, and all. Okay, then temperature, we need to have the temperature stresses changes. In case of, we need to have a data like when we want to design the joints also, we require the change in the temperature, what will be the change in the temperature in that area. Okay, so seasonal variation, daily variation, all this, I think this part we have discussed of factors which are affecting. It is just the repetition. Same wheel load and its repetition, how we need to take the standard load, convert all different axle into standard axle load of 8200 kg. Okay, so area of contact, for analysis purpose, we take the area of contact as circular, and the contact pressure what it is making, location of load with respect to slab. These are the critical load positions. Okay, interior, edge, and corner, strength of the concrete. So this is the repetition what one class I have discussed on these things, if I am not wrong. The same things I have discussed. Okay, so we'll come to the stresses in rigid pavements. Okay, how do you think that the strength or the stresses in rigid pavements are caused? What are the various stresses in rigid pavements? Can you name some of them? How the stresses are caused?
Temperature stresses.
Exactly. So when there is a variation in the temperature, there is always a stress which is caused. So we have temperature stresses. One with respect to daily variation, which causes wrapping of stresses, and one which is due to seasonal variation, wherein expansion of concrete takes place, contraction of concrete takes place. Because of this, one type of stress is caused. Which is that stress? Anyone apart from Tushar? When there is,
Frictional stress.
exactly, good. We have frictional stresses which are caused due to seasonal variation in the temperature. Okay, so when during summer the slab expands, during winter the slab contracts. So because of this, there is a frictional stress which is occur. Then there is daily variation. There is wrapping, curling of the slab upwards or downwards. Because of that, wrapping stresses are occurring in the ccpm. Apart from temperature stresses, what are the different stresses?
Wheel load stress.
Yeah, wheel load stress are the primary or the higher magnitude stress which are caused. Okay, so we need to analyze these stresses. One thing is wheel load stress, wrapping stress, and then frictional stress. These are the major stresses which are caused, and we'll be analyzing those stress. And these analysis was done by Westergaard. Okay, so the pioneering work in cement concrete slabs design was done by Westergaard in the year 1925. And these analysis, he made these analysis based on some assumptions. Okay, like what assumptions were made during initial stage of design of flexible pavement by Bazignes or by Burmisters, or 3-layer system, 2-layer system, all those things in the same lines. Okay, so there were certain assumptions. Always these designs were made certain, making some assumptions, so that they made the analysis simpler, or else this payment design is very complicated. It is dynamic in nature. Fine. So one assumption or first assumption was the concrete slab is homogeneous and isotropic and has uniform elastic property. So this was the first assumption what he made. The reaction of subgrade is vertical and is proportional to the deflection of the slab. In other words, the support provided by the subgrade is similar to that given by the dense fluid, and the subgrade has no shear strength. So this was the second assumption what he made. What is the second assumption? The reaction of the subgrade is vertical only and proportional to the deflection of the slab. It is behaving just like the dense fluid. This was the second assumption. Third assumption, the reaction of subgrade at a point is equal to K. So K is the modulus of subgrade reaction. Okay. So how do we get K value? What is the test we conduct to find out the K value? Capital K value or modulus of subgrade reaction? Anyone? It is something related to. Yeah, Prasad?
Coefficient of permeability is
Yeah.
coefficient of permeability, sir.
No, I am asking about how do you find out the K value?
Plate load test.
Yeah, plate load test. So this is the K value which we get through plate load test. We conduct plate load. Why we conduct plate load test is to find out the strength of the subgrade soil. Okay. So in case of flexible pavement, we go for CBR test. Same like that. For rigid pavement, we require this K value to find out the analysis. So K is the modulus of subgrade reaction which we get from plate load test. Fine. So the reaction of subgrade at a point is equal to K and directly proportional to deflection at that point. Okay. So this was the third assumption, and the fourth assumption is slab is uniform in thickness. So this was fourth assumption, and fifth one, the load in the interior and corner is circular in shape. Okay. So whatever that critical load position you saw, okay, the load in interior and corner is circular in shape, and the edge loading is semicircle. So let me take you to that slide. Yeah, you can see here the interior loading and corner loading are circular in shape, and edge loading he took it as an semicircular. Okay, this was the fifth assumption what he made. So these were some of the assumptions which he made to uh, simplify. Let me zoom in. Okay, so load in the interior and corner is circular in shape and positioned as indicated in figure, and the edge loading is semicircle. Okay, so these were the five assumptions he made, Westergaard, and then found out some equations to solve those stresses. Yes. Now, some of the technical terms which comes in analysis of rigid pavements are, please make this a point that these terminologies are asked repeatedly. I am very sure this time also it will be asked. One is modulus of subgrade reaction. They'll be asking the definition and the equation related to this. Okay. So modulus of subgrade reaction is nothing but the value of K and is proportional to displacement delta. Okay. And delta is always taken as 0.125 centimeters, and where P is the pressure sustained. This is the value of the modulus of reaction. This is the equation of modulus of subgrade reaction. Okay. And it is given by K is equal to P by delta. P represents here the pressure sustained in kg per centimeter square by the standard plate of 75 centimeter, or sometimes we go for 30 centimeter dia plate. Okay, so this is the equation to find out modulus of subgrade reaction. So I'll give different definition for this in the notes. Uh, Relative stiffness. Okay, so we always find relative stiffness before we analyze for say wheel load stresses. Okay, so what is relative stiffness? Certain degree of resistance to slab is offered by the subgrade. Okay, and this depends on stiffness or the pressure deformation properties of subgrade material. Slab deflection depends on flexural strength, and the resulting deflection is the direct measure of magnitude of the subgrade. Okay, so relative stiffness is defined as resistance to slab. Okay, certain resistance to the slab offered by the subgrade, and the resistance depends upon the stiffness properties of subgrade material. It depends on the strength properties of subgrade material, what the resistance to the slab. Okay, and the slab deflection depends on flexural strength of the slab, and it is a direct measure of magnitude of subgrade pressure. Okay, bit difficult to understand, but just memorize these definitions. These are very frequently asked in your examination. Okay, so Westergaard defined this value as the radius of relative stiffness, and it is always represented by small l value. Okay, so it is given by EH cube divided by 12K 1 minus mu square whole raised to 1 by 4. Okay, so here it depends, relative stiffness depends upon the E value. E value is modulus of elasticity of the concrete. H is the thickness of the concrete, and K is modulus of subgrade reaction. Mu is the Poisson's ratio of a cement concrete. So it depends on E, thickness, Poisson's ratio, modulus of subgrade reaction. That is the relative stiffness. Stiffness is resistance to the slab bend, which depends on the subgrade material, and then it also depends on flexural strength of the cement concrete. So in simple, you can define this relative stiffness. Okay, as I was telling you, L is the radius of relative stiffness. It is measured in centimeters. Okay, and E is modulus of elasticity of cement concrete in kg per centimeter cube. It should be. I am repeatedly telling this. This value of centimeter square is given in textbooks. A lot of textbooks. That's why I mentioned square here. So, but the unit for modulus of elasticity is kg per centimeter cube. Okay, and mu is Poisson's ratio, and if not given, we need to take it as 0.15. Okay, and H is the slab thickness in centimeters, and K is modulus of subgrade reaction, which is given by capital K, and it is kg per centimeter cube again. Okay, so related to wheel load stresses and related to relative stiffness, critical load position, so we'll be discussing in coming lectures. So I think today's class, most of the things, the factors affecting pavement design and all, it is repeated in module 5. Okay, the same thing you can refer, and then we'll be discussing in detail about the wheel load stresses and what were the Westergaard's equation on wheel load stresses, all those things. Is it clear?